Hello everyone and welcome to Quality Simplified, a YouTube channel dedicated to quality concepts. Friends, we are about to start a part 2 of session named Root Cause Analysis and Corrective Action. In first part, we have seen how to define a problem, collect data, and analyze it to see if any containment action is required at customer end, depending on the situation. In part 2, we'll be touching a most critical part of this process, wherein we'll be seeing how do we discover the root cause, introduce corrective action, preventive action at a system level to practically prevent occurrence of this defect forever. So let's begin with part 2. Hello everyone and welcome to Quality Simplified, part 2 of a session root cause analysis and corrective action. After going through defining problem well, handling containment action as required, in this part 2 we'll be discussing how to discover root cause and close with corrective action, and most importantly preventive action at system level. So let's proceed. Before we proceed in part 2, though this is repeat, let me share with you that these are purely my thoughts based on my experience in quality for 3 decades. I don't claim that this is the knowledge on quality. All viewers are free to have their own views on the subject, and I would be too happy to know your views, comment, so that we all can help each other in improving our understanding of quality at a concept level. Also, examples used here are with certain assumptions for the sake of ease of explanation. Viewers are requested to keep this in mind while watching this video. So with this, let's proceed further. Also, let's just reiterate our action points or mantra for delivering good quality to our customer. These are: know, identify your customer, understand the requirements in advance, which will help you to plan better. If you can get it directly from target customer, that would be a best possible scenario. Strive to satisfy maximum of these known requirements. And finally, receive feedback on quality delivered and act on it as required. To deliver good quality, we must remember and practice these mantras and make it a way of life. Discovering root cause. Friends, this is the most critical step in this whole process of problem resolution, and once concluded would mean major part of the work is done. There are no empirical formula or tool which will give you root cause without following steps and using domain knowledge. Many tools help you finding only root cause like a Ishikawa diagram. Some tools like AD helps you finding root cause, solution and close it, but they give only very broad triggers. However, in my view, Ishikawa diagram is the most effective tool helping finding root cause. Combination of Ishikawa and other tools like AD would be a good combination to resolve problem comprehensively. Various terms used in these tools are more closer to engineering businesses. However, they can be used to resolve problems in other businesses also, provided our understanding of these terms is very clear. As mentioned here, there are some popular tools or formats which are used to resolve the issue or finding a root cause. For example, 7-diamond process. It basically takes you through steps to check if part, process, tool used are correct as specified, and if all these are correct, then it is very likely that the process design, product design could be an issue. If we consider AD, this tool method helps you closing the problem more comprehensively. I feel the terms used here are much more general and can be used for non-engineering, non-manufacturing businesses also. Ishikawa diagrams helps you to know the root cause which led to problem, defect generation, misinspection as well. but it does not guide you through the data collection, definition, or closure, etc. To find root cause, first we need to understand stage, location, where the defect must have got generated or must have got detection, misdetection. To know this, let us start moving backwards from where we notice the defect in process flow. Now ask two questions at each stage. Can the defect get generated here? Did it miss the planned inspection check here? If I follow this methodology, for example, where defect is diameter oversized by 0.1 mm. Let's see what happens. First, we approach a dispatch where inspection is not planned and no question of missing it. Also, the defect is not generated here. Then we reach final inspection where we find defective part has missed the detection here. Then comes the stage where the oversized diameter is generated and has misinspection as well. Once we know these points, we have to have detailed investigation to know why this is generated or missed using Ishikawa diagram. In this example of oversized pin, we find the detection is missed at two locations, before final dispatch and at a point where it got generated. We'll have to carry out separate investigation to understand why it escaped inspection in both the locations as well as why it got generated. After knowing the stages where the defect got generated or misdetection, let's investigate why the defect got generated using Ishikawa diagram as example. Using example of oversized pin, if we follow the areas in Ishikawa diagram, that is man, machine, material, method, measurement or environment, we find it was method where setup piece sample got mixed with regular production pieces. There is no proper process to identify or scrap, dispose of these pieces. Guideline for handling of these test setup pieces samples is not adequate, so its compliance does not stop these pieces from getting mixed with production parts and reaching customer. Similar investigation would be necessary for the areas where it has missed detection. Once root cause is known, devising solution is relatively easy. At times, you may have more options for solution, like it could be completely automatic, semi-automatic, manual. Choose final solution based on the other conditions, like if the defect is seen on many occasions before, if the customer is very critical, cost of handling defect, cost of solution, how frequently solution will be used, etc. Please verify, validate solution on limited numbers, smaller batch to see its effectiveness and if it is giving any undesired side effects. Once confirmed, go for a full-fledged implementation. Till then, measures such as extra inspection should be introduced temporarily. If the solution involves product design or process design change, must be validated. You may choose your methods to validate. However, the method should be reliable and relevant. The solution finalized, for example of oversized pin, here is to identify the setup parts and destroy them physically. Once solution is finalized and introduced, it is always better to look for opportunities to deploy same solution horizontally where similar situation or chances of such lapse exist. This will save effort, money, time, and potential loss and correct situation before such lapse occurs. For example, in this case, the similar situation could be we have a process rejection which can get mixed. We have a rejection returned by customer which can get mixed, or there could be many parts which are not identified with no confirmation of its status can also get mixed. So in this example where Oversized pin produced during setup trials got mixed up with regular production piece and reached customer. The solution device must involve revision of guidelines for handling disposal of setup samples, which may bring in better identification methods, segregation, and disposal scrapping of these pieces. The root cause on surface may seem inadequacy of guideline for handling setup samples. But if I ask you a question, why such basic inadequacies were present in guideline? Was it written by a person who is not trained enough? Was it not checked, tried, validated before release? If we are able to get answer to these questions and close it, then we'll be able to correct the system and prevent recurrence. This is how any issue will get generally a level where you observe how system lacuna gives rise to defect. Hence, complete closure with preventive action can take place only if system level cause is found and corrected. The document to be updated could be engineering drawing, any QMS document like format, procedure, work instruction, guideline, engineering drawing, etc. So friends, based on this discussion so far and based on my experience in this field, I suggest following steps to be followed in finding root cause and resolving it completely. Record customer complaint in customer's verbatim. Convert complaint into scientific definition by asking questions, deeper probing to elaborate nature of complaint in more actionable form. Collect relevant data around complaint. This will explain scale, scope, intensity of a problem and help in deciding if any containment action is required at customer ends. Decide on containment action required if any and inform customer accordingly. Discover the root cause, decide the location of generation of defect in process flow, decide the location where it must have misdetection, which could be more than one, investigate the reason of generation and misdetection, fill in separate form for each lapse or misgeneration. Devise the solution, verify, validate the solution as required, implement on small numbers, smaller batch, check for undesired outcome if any, and if okay, implement 100%. Look for horizontal deployment opportunities. Ensure that the root cause reaches the system level labs to introduce preventive action. Close the problem and appreciate the team efforts. Do not follow any format tool blindly. Understand concept behind each step before you use it. So friends, before we close, thanks for listening to me till end, and I'm sure you must have got a clear idea of how to follow various steps in root cause analysis and corrective action. Also, please note that problem solving tools alone cannot solve the problem. We must have and use domain knowledge also. So friends, if you like this video, then please subscribe the channel, recommend others to subscribe, watch and like. Also, please let me know if the knowledge information shared is helping you and if you need any specific area to be added in future videos through comments. So friends, with this, let's meet in next video session where we'll go one more step ahead in understanding conceptual quality. Till then, goodbye.